Hi, my name is Corey Johnson with DCS, and today's video we're going to be going over conditional logic. This is the second video on the topic, and today we're going to be focusing on using conditional logic in more of a real-world scenario, in this case, the auto industry. So for this example, we have two door assemblies. And both door assemblies, when brought to the line, are located using a combination of fixture pads, here in yellow, and pins that go into holes in slots, respectively, here in the green and red arrows, for the secondary and tertiary controls. Likewise here for the front door. Now, for any door-to-door relationship, there's always a requirement to maintain an acceptable gap condition along the entire length of the door-to-door interfaces. For this example, we're going to be using a gap requirement of plus or minus 0.7 millimeters. Now, I put this pink line here to show why the conditional logic can help us and why an adjustment is necessary sometimes. So as you can see, the gap condition here is in the X direction. And that four-way for the front door, which is our only X control for the assembly, is kind of in the middle and towards the front. So if you were to draw a line that I have here in pink, you would anticipate a measurement that is more or less in the middle, measuring the gap front door to rear door, would be okay within spec. But naturally, the further you go away from this line, the worse the result is going to be. Which is why sometimes in the auto industry, they need to make an adjustment at the front, the top, the middle, depending on the geometry of the assembly. In this case, we would likely see problems at the front and the very bottom of these door assemblies. For this example, we are going to be focusing on the top and adjusting up there. Now, here are the door assemblies in their built positions via their fixture locating features that we just went over. Now, as I mentioned, when these door assemblies are brought to the fixtures, they're going to measure the gap. And if the gap is out of spec, they're going to use what's known as a margin blade or a gap setting tool. It's just going to go in there and pick up off of each gap feature on each door and adjust it to get those gap measurements within spec. So briefly, we're just going to go over these moves really quick. This is our first move. We're going to bring the rear door in there. 3 primary here in yellow, which represent the fixture pads, and then a combination of the 4-way and the 2-way that are going to constrain our secondary and tertiary controls. Same thing goes for the front door. 3 primary, and then we got our 4-way and our 2-way. Now, these moves are already in the model, so I just wanted to go over them briefly so we all understand what's going on here. And after those moves, you're going to want to measure. And as I mentioned, we're going to focus up here at the top, but the same example or study could be done here at the bottom. And what we're going to do at the very top is add a gap measure, a simple point-to-point measure, and we're going to see what the gap condition is without any adjustment, just what the condition is or the result is when these door assemblies are held by their respective fixtures. And when we add that measurement, it's a simple point-to-point, front door to rear door. Now we got to maintain, or capture that gap condition of plus or minus 0.7 millimeters. So to do that, we're going to take our nominal gap, which is here, which can always be found after hooking up a point-to-point measurement. You can hit that current button and it's going to tell you what the gap condition is, what the nominal gap is. So if I want to evaluate a plus or minus 0.7 millimeter, all I have to do is add 0.7 and subtract 0.7 from that 6.5 nominal gap, which is what you would see here. So 6.5 plus 0.7 is 7.2. 6.5 minus 0.7 is 5.8. So let's take a peek at the model here. We have our rear door move and our front door move. As you can see, these surfaces here, that's where the fixture pads pick up off of. They're all over on each door. And if I had to turn this assembly here and look on the inside, this is where the hole is and the slot is that the fixture pins would pick up off of these doors. And if I highlight the rear door, you can see the same thing. Fixture pads on the outside, 4-way there, 2-way there. So that's how these doors are held by the fixture. And then I have that measurement that I just went over here with the current nominal gap of 6.5 and capturing that spec limit, that capability I want to check of plus or minus 0.7. So my spec limits are good. This measurement is good. My moves are good. And this is just kind of showing the sequence. Rear door goes in there, then the front door. So let's go ahead and run this. And we're going to look at this result. So right now, just based off of the tool setting features, when the front door and the rear door get brought in there, our gap at the very top of this door-to-door interface is out of spec roughly 12.5% of the time. So now we want to mimic that adjustment via that margin blade or that gap setting tool to improve that result. So I'm going to pop back open the slide really quick. This is going to be the third move that we're going to have to add. We're going to be leaving the rear door alone. We're only going to be adjusting the front door relative to the rear door. So our primary is going to stay the same. 3 surfaces that those fixture pads pick up off of. And we're still going to use the 4-way and 2-way hole and slot respectively. But we have to account for that margin blade. And this is going to be our adjustment. And that is going to be a point on the front door and on the rear door up here where that tool picks up off of. And that is going to be our X control. So the only thing that's going to change really from our first move of the front door is this tertiary control. So I know this can get confusing, so let's take a closer look here. So we have an image here because we have a couple things going on. And again, this is for the adjustment of the front door. The very top is the measurement that we added. This is the measurement that is out of spec 12.5% of the time. Then we needed to add the points that represent that margin blade, that gap setting tool. That's just below it on more of a main surface here. So we have 2 sets of points. So to make this adjustment move, we're just going to create a copy of our original front door move. And the only thing we want to change is the object in target 6. We want to change it from what is the 4-way to this gap setting tool, this area here where this margin blade would pick up off of and adjust. Now once we change that, all we have to do is go into our options, which is going to bring up this dialog box. And now we got to take care of the conditional logic side of things. Now, all we have to do is go under this conditional logic area here, is we need to select that measurement that is out of spec 12.5% of the time. And then we want to make sure that we say execute or check execute if out of specified limits. And what this is saying is, here's a little snapshot of that original measurement. When this measurement is out of spec, we want this adjustment to happen. which is exactly what they do on the plant floor. And what I mean by that is if the front door and the rear door are located via their tools and they check the gap, there's no point in adjusting. So we don't want to override any of that, the original move. We only want to add this adjustment or adjust this front door if this gap measurement is out of spec. And that's exactly what we accomplish using conditional logic, hooking it up with that measurement and telling it to execute if it is out of its specified limits. And once we do that, and we add that adjustment, we should be able to pop open that measurement and look at it and see that the out of spec has been drastically reduced and we have improved our results and mimic what has happened on the plant floor in the adjustment that they make. So let's go back to the model and take care of this. So as I mentioned, we're just going to be, our rear door is fine. We're just going to make a copy of our front door. And the only thing we got to change is our object in target 6 here. So my object 6 is going to be my gap set, and my target 6 is going to be my gap set here. Now, all I have to do now is go into options. I got to select the condition, which is that measurement. Now you can pick from here in the drop down, or you can also just select pick from tree, find the measurement in your tree and select it, either or. And then, yep, just select execute if out of specified limits. And that's all there is to it. So I'm going to update my model and just point out one other thing. So let's take a look here at this gap set point here. Set here on the front door, and the rear door point is there on the rear door. Now there is a gap of about 6.3 millimeters, somewhere in that range. And I created an offset of one of the points, in this case the rear door. So I offset this gap set point, that nominal gap here, that distance, so that both of the points that I'm using in the move are on the same plane. It's something to be cautious of, and the reason being is that if your points are on the same plane or they're coincident, you won't get a mean shift. But if I were to use just these 2 points here and here, as you can see, there's a distance between them. It's going to try to, the move operation will try to bring the points together, and you'll get a mean shift that's not there in the real world. So it'll be different example to example, but just make sure in a case like this, you need your points to be at least on the same plane so you don't get a mean shift. So I'm just going to name this adjustment of front door. Cool. We can update, we can nominally build, and we can run. And we're going to take a look at that measurement now with this adjustment in here. And you can see, yeah, we're out of spec only less than 1% of the time, which is awesome. And you can further make this result better by tolerance refinements and maybe an additional adjustment. You can, there's a lot you can do with it, but this is just to show the capability of conditional logic and kind of how it applies in this kind of scenario. So I hope this helps. I thank you for watching, and have a great day.